Hey, it's Kaylee. Ready for the final video on least common multiples? In this video, we will jump into some real-world examples where we use least common multiple. Can you think of a time when you need to know the least common multiple of two numbers in the real world? What if we have to add two fractions with different denominators, like 1/3 and 1/5? What do we need to solve this problem? Yeah, that's right. We need to find a common denominator. In order to have the most simplified fraction, it would be clever to have the least common denominator. That means we would use the least common multiple of 3 and 5 as our new denominator. So let's do a quick prime factorization for 3 and 5. So my tree for 3 will give me 3 and 1. And how about my tree for 5? It will give me 5 and 1. And that's it, right? So my LCM for 3 and 5 have to represent my 3, which is 3 times 1, and my 5, which is 5 times 1. I already have that 1 right there, so I'll just add my 5. And this is really just saying 3 times 5, which is 15. So the LCM of 3 and 5 is 15. So that's what my least common denominator would be. So if I have to change my fractions now, down here at the bottom, to make 3 15, I'd have to multiply by 5. So I have to do the same thing to my numerator. And to turn 5 into 15, I multiply by 3. So I have to do the same thing up here. And this would give me 1 times 5 is a 5 on top. And I know my denominator is 15 here. Plus 1 times 3 would give me a 3 on top with a 15 down here. And this is equal to, we add across our top, 5 and 3 give me 8 15ths. So this is something we have to do all the time, right? Is add or subtract fractions that don't have the same denominator. But now we can just use the LCM and we quickly figure it out. Now let's think about another use of least common multiple in the real world. Joe and Dave are running on a circular track. Joe is running around the track in 6 minutes. Dave is running around the track in 8 minutes. If they started running at the same place at the same time, how long until they meet at the same place on the track again? Can you think of a method to solve this problem? Well, what are we really trying to calculate? The least amount of time that Joe and Dave will have their locations in common. So what we need to find is the least common multiple of 6 minutes and 8 minutes. Let's make our prime factorization tree for 6 and 8. So for 6, I break into 2 and 3. And for 8, I break into 2 and 4, and 4 breaks into 2 and 2. So my LCM for 6 and 8 will be, well, to represent my 6, I need to have 2 times 3. And to represent my 8, I need to have 3 2s, but I already have 1 2 down here, so I need to add 2 more here. And then all I need to do is multiply these out. So 2 times 3, that will give me 6, and 2 times 2, that gives me 4, and this is equal to 24. So what does that 24 really mean? That means 24 minutes is how long Dave and Joe have to run around this track until they both pass at the starting place again. So we've used the least common multiple of 6 and 8 to figure out when Joe and Dave will be in the same place again. Thanks for doing those practice problems with me. Now you're ready to practice on your own. If you get stuck, you can go back and watch any of the least common multiple videos again, and the prime factorization video. You've got this. Have fun, and remember to always be clever.